Welcome to class. I'm Olivia, everyone's favorite math teacher, and today we're going to talk about zero. Specifically, why you can't divide by zero, and we're going to look at it in 3 different ways. Our first method is going to be division by grouping. Now, when we talk about division by grouping, we literally mean taking some amount of objects, some amount of things, and breaking them up into groups, equal groups of objects. A classic example is you have 6 apples shared among 3 people. How many apples does each person get? So you put 3 circles in the group so that each circle contains the same amount of stuff, and it's 2. Everything has to have 2 objects. And you can draw your circles however you want. You can get fancy with them, and it doesn't matter. The point is, 3 circles each contain 2 objects. That's division by grouping. So the problem comes up when you say, okay, if we wanted to make one group, it would have 6 objects. If we wanted to make 2 groups, it would have 3 objects. And at this point, we haven't really talked about fractions and things like that yet, so don't worry about those. We're just working with whole numbers. So then if you ask, can you make 0 groups? Well, the problem is, no, you can't. Those objects exist. And if you don't circle any of them, you still have the objects there. And they're still existing, and it's still a group of 6 objects, whether you draw the circle or not. The circle is kind of a formality. You could also just move the objects apart to indicate grouping. It doesn't matter. The point is, without subtraction, without physically removing the objects, you can't actually make 0 groups. There's always going to be a group that contains something. So, division by grouping, it's impossible to divide by 0. Next, we're going to look at division as fractions. At this point, talking 5th, 6th grade, we are demonstrating that fractions are numbers and division problems, and we are looking at them with operations as well. Okay? So before we get into this, I'm just going to quick reminder. The parts of a fraction, and these are kind of important, we have the numerator, the top number, and we have the denominator, the bottom number. The way that I help students remember what these are and what they do is that the numerator is the number of the fraction. It counts how many of the fraction we have, and the denominator denotes the type of fraction. It tells us what kind of fraction we have. Okay? So 2/3 literally means I have 2 1/3, and 5/3 is 5/3, 5 1/3. Okay? So you can think of this like if you take a pizza and cut it into 3 equal pieces, you have 2 of those pieces, one of them's already been eaten. And then 5/3 would be, well, if I had 2/3 of my pizza in one box and then another box that had a whole pizza, I have 5/3 of pizza, because I could cut both pizzas into thirds. Okay? And then also for fraction addition, remember that because we're adding a thing, a third, this is why fraction addition kind of works the way it does. We have 2/3 and 5/3. And if the thirds part is giving you problems, just think of it like we were talking about apples again. 2 apples and 5 apples is 2 plus 5, 7 apples. In this case, it's thirds instead. Thirds of pizza. Whatever. Now, with our bigger, further into school brains, we know that 7 is also 3 plus 3 plus 1. Which means we can reverse the addition we did earlier, only using 3 this time. And this is where one of the important things comes in. The denominator tells us what kind of fraction, but it also tells us how many of that fraction we need in order to make a whole unit. So if I wanted to make a whole pizza out of thirds of pizza, I need 3 of those thirds. So 3/3 and 3/3, 1 plus 1, that's 2. That's where we get the 2 in the 2 1/3 over here. Okay? Now, we're going to look at division by 0 as a fraction using this framework to show why you can't divide by 0. First off, just thinking about it under the idea of the denominator tells us what kind of fraction it is, or how many pieces we broke our object up into. Well, 2 0ths would mean that we took some object and we broke it into 0 pieces. So again, we're kind of breaking the laws of thermodynamics, and we're saying we have a thing, and through the power of going, I'm going to break it into pieces to give to people, I now have a nothing. It's just ceased to exist. I break it in half, I've got 2 halves. I break it in 3 pieces, I've got 3/3. I somehow go 0ths. What? How does that work? I should have a thing and then not thing, right? So that's one of the problems. It just doesn't make any sense. But mathematically, if we look at it the same way we did this, you're going to see it also doesn't really make sense. Because one of the other properties of 0 is that you can add 0 to something as much as you want, which means 2 over 0 is the same thing as saying 2 plus 0 over 0. And by our fraction addition, that means that this is 2 over 0 plus 0 over 0. But wait, we need 0/0ths to make a whole. So that means this is 2 over 0 plus 1. But I can do this as many times as I want because I'm not changing anything. Which means I can go, oh, well, 2 plus 0 plus 0 plus 0 over 0. And that becomes 2 over 0 plus 0 over 0 plus 0 over 0 plus 0 over 0. Wait a second. So 2 over 0 is equal to 2 over 0 plus 1. So it's equal to 1 more than itself. But also, 2 over 0 is 2 over 0 plus 1 plus 1 plus 1. So it's also equal to 3 more than itself. But it's equal to itself. So it's equal to anything? Because we still don't know what this is. Because every time we try to do something, we get this back out. So, therefore, this is an undefined operation because I don't know what it is. Do you know what it is? Your guess is literally just as good as anybody else's because all of the answers are correct and also none of them are correct because none of them explain how this happens. So this is an undefined operation. And that brings us to our final method, which is going to be division as the inverse of multiplication. And as you can see by the letters, we're going to step forward a little bit more into algebra, pre-algebra, we're talking 8th, 9th grade here. So the way we're defining division here is being the inverse of multiplication. That means that m over n equaling p infers that m has to be p times n. So because we're talking about division by 0, we're going to let n be 0. And this gets us into an interesting situation. M is equal to some number, a number, okay, times 0. If this is something that can be done, if this exists, okay? And we can easily show what's happening here by breaking this into 2 situations. Either m is 0 or m is not 0. Okay? Now, if m is a number that is 0, that means that 0 over 0, a thing divided by itself, would be 1, so p should be 1. And that's simply not the case here, because p can be literally anything, because 0 times anything is 0. So any value of p makes this true, but this says the value has to be 1. But again, no, it doesn't. By being the inverse to multiplication, this is true with absolutely any value, 0 included. So that means that 0 over 0 is equal to 0, but 0 over 0 is also equal to 1, and 0 over 0 is equal to 7, and 0 over 0 is equal to 50. Okay? And this is very similar to our fraction example, but this time we're using literally just the properties of multiplication, multiplying by 0. Now, the other option is, okay, so m being 0 doesn't work, creates a paradox. The other option is m does not equal 0. But again, this creates a paradox because anything times 0 is 0. Absolutely anything. Just by the definition of multiplication. You take a thing that's there and you say you have none of it. So therefore you have nothing. Because you have said you have none of whatever that thing was. And it doesn't matter if that thing is nothing or if that thing is something. If I say I have none of it, I have none of it. I have 0, right? That's how multiplication works. So therefore, m can't possibly be a non-zero number, but it also can't be 0. And those are our only two options in standard arithmetic and algebra. So again, you can't divide by 0. It creates a paradox. It is an undefined operation. However, the fact that we can't divide by 0 is actually why we created calculus. We still can't divide by 0, but we can create a nifty trick that kind of gets around it a little bit. But that's a topic for another class. Thank you for attending class today, and I hope you enjoyed this little lecture about why you can't divide by 0. If you have any questions, comments, or examples, feel free to share them with the class. Have a great day, and I'll see you next time. Bye.